March 15, 1944. 8,000 feet above the Normandy coast, Captain Robert S. Johnson watches his wingman's P-47 Thunderbolt disintegrate. The Focke-Wulf 190 that killed him pulls up vertically, effortlessly climbing away from Johnson's own aircraft. Johnson pushes his throttle to war emergency power and hauls back on the stick. The Thunderbolt, all 7 tons of it, claws for altitude. The German fighter climbs faster. This is the nightmare scenario every Thunderbolt pilot dreads. The FW-190 can outclimb them, outroll them, and tear them apart before they can respond. Johnson's airspeed bleeds away as his nose points skyward. The German is already 500 feet above him, banking to dive back down for the kill. Johnson's hand moves to the flap lever. Every flight manual, every briefing, every instructor has hammered home the same warning. Never deploy flaps in combat. They'll tear off at high speed. They'll slow you to a crawl. They'll make you a sitting duck. He pulls the lever anyway, 15 degrees. The Thunderbolt lurches upward like someone cut its chains. In the 30 seconds that follow, Johnson does something that Air Force technical manuals will later classify as aerodynamically impossible. He outclimbs a Focke-Wulf 190 in a straight vertical contest, gets on its tail, and sends it spinning into the channel in flames. Within 6 weeks, every P-47 squadron in the European theater will receive a classified tactical bulletin reversing 2 years of official doctrine. The forbidden technique will become standard procedure, and the Luftwaffe's most reliable tactical advantage will evaporate overnight. By early 1944, the Republic P-47 Thunderbolt had established itself as the heaviest single-seat fighter in operational service anywhere in the world. Weighing 1,700 pounds fully loaded, powered by the massive Pratt & Whitney R2800 double wasp engine, producing 2,300 horsepower, the Thunderbolt could absorb catastrophic battle damage and dive faster than anything the Luftwaffe could field. But it couldn't climb worth a damn. The problem was simple physics. The P-47's wing loading, the aircraft's weight divided by its wing area, was substantially higher than any German fighter. At 47 pounds per square foot, the Thunderbolt needed more airspeed to generate the same lift that a Focke-Wulf 190 could produce at lower speeds. In practical terms, this meant that in any climbing engagement, the German fighter held a decisive advantage. The statistics backed up what pilots already knew viscerally. In vertical maneuvers below 15,000 feet, the FW-190 could outclimb a Thunderbolt by approximately 800 feet per minute. In combat, this translated to life or death. A German pilot with any tactical sense could simply climb away from pursuing Thunderbolts, reset the engagement on his own terms, and dive back down with altitude and energy advantage firmly in hand. For 18 months, 8th Air Force P-47 squadrons had struggled with this fundamental performance deficit. Tactical doctrine compensated by emphasizing the Thunderbolt's strengths: high-altitude performance, diving speed, and devastating 8-gun firepower. Pilots were taught to maintain altitude advantage, never allow themselves to be drawn into low-altitude turning fights, and use hit-and-run tactics that played to the aircraft's rugged construction and superior dive performance. The problem was that bomber escort missions didn't always allow such tactical flexibility. When German fighters dove through bomber formations, Thunderbolt escorts had to follow them down. Recovery to altitude then became a desperate race against physics, with FW-190s and BF-109s holding every advantage. Between January and March 1944, the 8th Air Force lost 278 P-47s. While many fell to ground fire and bomber defensive crossfire, a significant portion died in low-altitude engagements where German fighters could dictate the terms. Major General William Kepner, commanding 8th Fighter Command, wrote in a February 1944 assessment, The P-47 is without question the finest high-altitude fighter in our inventory. Below 10,000 feet against the FW-190, it is at a severe disadvantage in any maneuver requiring rapid climb performance. Republic Aviation's engineers understood the problem. The company had proposed various modifications: paddle blade propellers for improved thrust, water injection systems for emergency power boosts, even experimental wing designs with increased area. All showed promise. None could be implemented quickly enough to affect the current operational crisis. What made this situation particularly frustrating was that the P-47's massive engine produced more raw horsepower than any German fighter. The R-2800 generated nearly twice the power of the BMW 801 radial in the FW-190. Yet in climbing combat, power alone couldn't overcome the tyranny of wing loading and aerodynamic efficiency. Test pilots at Wright Field had explored every possible avenue for improving climb performance within the aircraft's existing design. They'd experimented with propeller pitch settings, manifold pressure limits, and various combinations of mixture settings. Marginal improvements resulted, but nothing that fundamentally altered the climb rate equation. The solution, when it came, wouldn't emerge from engineering analysis or wind tunnel testing. It would come from a desperate pilot in a life-or-death situation, disregarding everything he'd been taught about proper aircraft handling. German fighter pilots had learned to respect the Thunderbolt's strengths while exploiting its weaknesses with near-scientific precision. Luftwaffe tactical bulletins from early 1944 reflected this calculated assessment. One captured document from Jagdgeschwader 26 instructed pilots, "The P-47 is dangerous only when it holds altitude advantage. Force the American to climb, and you control the engagement." They weren't wrong. Oberleutnant Joseph "Pips" Priller, commanding JG-26, had built his defensive tactics around this principle. When Thunderbolt escorts appeared, his fighters would make aggressive head-on passes through bomber formations, then dive away and climb back to altitude, while American fighters struggled to pursue. The technique worked with devastating consistency. 8th Air Force pilots understood they were fighting with one hand tied behind their backs. Lieutenant Colonel Hub Zemke, commanding the 56th Fighter Group, wrote in his after-action report from a March 8 mission, "We splashed 3 190s but lost 2 aircraft to a climbing scissors maneuver that we simply couldn't counter. The Germans know our aircraft better than we do." American training doctrine compensated by teaching energy management rather than turn performance. Fighter schools emphasized maintaining speed, avoiding sustained turning engagements, and using the Thunderbolt's superior dive performance to escape unfavorable situations. The phrase repeated in every briefing was boom and zoom. Dive in fast, hit hard, climb away using speed, never get slow. But bomber escort missions made that doctrine nearly impossible to execute perfectly. When German fighters attacked B-17 formations from above, Thunderbolt pilots had no choice but to engage. Regardless of altitude or energy state, they'd dive down to break up the attacks, succeed in driving the Germans away, then face the agonizing climb back to escort altitude, while FW-190s circled above them like vultures. Several squadrons had experimented with keeping sections of fighters at maximum altitude as top cover while others escorted the bombers directly. This helped, but it meant fewer fighters directly protecting the bombers, and German tactics adapted quickly. They'd send decoy formations to draw down the high cover, then strike with fresh fighters once the Americans were committed low. Republic's test pilots had explored every corner of the P-47's performance envelope, or so they thought. The tactical manual was explicit about combat flap usage. Flaps may be used at speeds below 150 miles per hour to tighten turning radius in emergency situations. Under no circumstances should flaps be deployed above 200 miles per hour or in climbing flight. Structural failure may result. That warning had been validated in testing. Flaps deployed at high speed created massive drag and structural stress. Every pilot who flew the Thunderbolt knew the flap lever was for landing and tight, low-speed turns only. Then came a combat mission that would force one pilot to violate that absolute prohibition. What he discovered would render 2 years of tactical doctrine obsolete in a single engagement. Captain Robert S. Johnson was not a novice. By March 1944, the 28-year-old pilot from Lawton, Oklahoma, had flown 73 combat missions with the 56th Fighter Group. He'd survived being shot up so badly the previous June that he'd limped back to England with 21 cannon shell holes in his aircraft. The Luftwaffe knew how to kill pilots. Johnson knew how to stay alive. The mission on March 15th was a standard bomber escort to aircraft factories near Paris. Johnson's flight of 4 Thunderbolts was providing close cover for the lead B-17 box when German fighters appeared at 1 o'clock high. Standard engagement, the FW-190s dove through the formation, firing, then pulled up hard to climb away. Johnson's wingman, Lieutenant James L. Stewart, pursued one of the 190s down through the bomber formation. Johnson followed, calling warnings as Stewart fixated on his target. The problem with target fixation is you stop checking your 6 o'clock. The second FW-190 came from above and behind. Johnson saw it before Stewart did, screamed the warning over the radio, but the geometry was already wrong. The German's 20-meter cannon fire walked up Stewart's fuselage. His P-47 nosed over and went down, trailing smoke and pieces. The FW-190 that killed Stewart pulled vertical, full power, climbing away. Johnson pushed his throttle to war emergency power, 2,535 horsepower, manifold pressure redlined at 56 inches. He pulled back on the stick and pointed his nose at the clouds. The Thunderbolt accelerated in the climb initially, using kinetic energy from the dive. But physics is unforgiving. As airspeed bled off from 350 miles per hour to 280 to 240, the climb rate decreased proportionally. The altimeter unwound, 8,000 feet, 8,400, 8,700. The FW-190 was already at 9,500 and still climbing hard. Johnson held the climb. His airspeed dropped through 200 miles per hour. The German was 1,000 feet above him now, banking left to reverse and dive back down. Johnson had maybe 10 seconds before those 20mm cannons tore him apart like they'd torn apart Stewart. The control stick felt mushy in his hands, the Thunderbolt approaching the edge of its slow flight envelope. Johnson knew the energy equation was hopeless. He couldn't outclimb the 190. He couldn't dive away without giving the German a perfect deflection shot. Turning would bleed even more airspeed and make him a stationary target. His left hand dropped to the flap lever. Every instructor's warning echoed in his head. Every manual's red-lettered prohibition. But Johnson had flown crop dusters in Oklahoma before the war. He understood lift. More wing surface meant more lift at lower speeds. Flaps increased wing area and camber. They'd generate more lift right now at this precise moment, even if they also increased drag. He pulled the lever to 15 degrees. The hydraulic actuators whined. The trailing edge flaps extended down and back. The Thunderbolt lurched upward as if kicked from beneath. Johnson felt himself pressed down into his seat. The vertical speed indicator, which had been showing a weakening 900 feet per minute, jumped to 1,400. The aircraft's nose pitched up further, and Johnson had to push forward on the stick to keep from stalling. The German pilot above him saw the Thunderbolt's sudden acceleration. His 1,000-foot altitude advantage shrank to 800 feet, then 600. He rolled into his attack dive, but the geometry was changing faster than he could compensate. The slow-moving target he'd expected to be lining up in his gun sight was suddenly climbing at a rate that matched his own best performance. Johnson watched the 190 grow larger in his windscreen. His airspeed held at 195 miles per hour, dangerously slow for combat, but the flaps were generating lift that normally required another 40 miles per hour. He reached 9,800 feet, then 10,000. The German leveled off at 10,500, turning hard to regain position. But Johnson wasn't finished climbing. He pulled the Thunderbolt's nose up another 5 degrees. The aircraft shuddered on the edge of accelerated stall, but the flaps kept generating lift. He passed through 10,500 feet, with the FW-190 now directly off his left wing, barely 300 feet away. Both aircraft were slow, both vulnerable. Johnson kicked right rudder, aileron coordinated, and brought his nose around. The German saw the movement and snapped into a hard left roll. The FW-190's superior roll rate should have given him the advantage, but Johnson had altitude and angles now. He fired a 2-second burst from all 850 caliber Brownings, 2,600 rounds per minute, convergence pattern set for 300 yards. Tracers walked across the 190's engine cowling. The BMW 801 radial engine took multiple hits. Black smoke erupted from the cowl flaps. The German rolled inverted and pulled through toward the deck. The classic escape maneuver that should have worked because Thunderbolts couldn't follow 190s in a vertical dive and climb sequence. Johnson retracted his flaps, pushed his stick forward, and dove after him. The Thunderbolt accelerated quickly in the dive. This was what it did best. He closed to 250 yards and fired again. More hits stitched across the 190's wing root and fuselage. The German fighter snap-rolled to the right, pieces coming off, then went into an inverted spin. Johnson pulled out of his dive at 4,000 feet and watched the FW-190 hit the channel 8 miles north of Dieppe. The entire engagement, from Stewart's death to the German splash, had lasted 90 seconds. Johnson's hands were shaking as he retracted his landing gear. He'd forgotten he'd dropped it as well as the flaps in his desperation to generate lift. The Thunderbolt hadn't torn itself apart. The flaps hadn't ripped off. Every prohibition in the manual had been wrong, or at least incomplete. Johnson returned to Halesworth with 12 gallons of fuel remaining and a combat discovery that would change 8th Air Force tactics for the rest of the war. When Johnson climbed out of his cockpit and described what he'd done, his squadron engineering officer initially didn't believe him. Deploying flaps at 200 miles per hour in a climbing attitude violated every structural limit in the P-47 technical manual. The aircraft should have experienced catastrophic structural failure or entered an unrecoverable stall. But Johnson's gun camera footage told the story. Frame by frame, the film showed the Thunderbolt's sudden climb rate increase, the changing angles as Johnson matched and exceeded the FW-190's vertical performance, and the final sequence where an American fighter did what American fighters weren't supposed to be able to do. Within 48 hours, Republic's test pilot at Farmingdale, Mike Ritchie, was running flight tests with a P-47D at various speeds and flap settings. What he discovered fundamentally changed the understanding of the Thunderbolt's aerodynamic behavior. At speeds between 180 and 220 miles per hour, deploying flaps to 15 degrees increased lift coefficient by approximately 30%, while only increasing drag by 20%. The net result was a measurably improved climb rate, roughly 400 additional feet per minute at the bottom of the speed envelope, where combat often forced pilots to operate. The reason this had never been discovered in testing was simple. No test pilot had ever tried it. The manual said don't deploy flaps in climbing flight. Test protocols followed manual limitations. Combat pilots, trusting the manual, never experimented with techniques they'd been explicitly told would kill them. Major General Kepner ordered immediate verification through operational testing. The 56th Fighter Group assigned 6 pilots to conduct combat trials using flaps during climbing engagements. Over the next 3 weeks, these pilots recorded 17 encounters where flap-assisted climbing either enabled them to match German fighters in vertical maneuvers or gave them sufficient climb performance to avoid being trapped in disadvantageous positions. The limitations quickly became clear. Flaps at 15 degrees worked in the 180 to 220 mile per hour envelope. Above 220, structural stress increased dangerously. Below 180, the aircraft was too slow for combat maneuvering. The technique required precise airspeed awareness and immediate flap retraction once the tactical situation allowed normal flight parameters to be restored. Intelligence officers realized they'd stumbled onto something the Luftwaffe couldn't easily counter. German fighter tactics had been built on documented P-47 performance characteristics. If Thunderbolts suddenly demonstrated climb capabilities that exceeded their known specifications, German pilots would face tactical situations they'd trained to avoid. On April 12, 1944, 8th Fighter Command issued Tactical Bulletin 4744, classified restricted. The bulletin reversed the absolute prohibition on combat flap usage and provided specific guidance. In climbing engagements below 250 miles per hour, pilots may deploy flaps to 15 degrees to temporarily improve climb performance. Flaps must be retracted when speed exceeds 220 miles per hour or when tactical situation permits. This technique may produce climb rates approaching 2,000 feet per minute at airspeeds where normal climb performance would be significantly degraded. The bulletin went to every P-47 squadron in the 8th and 9th Air Forces. Training officers were directed to incorporate the technique into combat instruction. Engineering officers were tasked with monitoring flap actuator wear and structural stress, though initial evidence suggested the technique, properly executed, fell within the aircraft's structural margins. What made this discovery particularly valuable was its psychological impact. Thunderbolt pilots who'd felt disadvantaged in climbing engagements suddenly had a technique that negated German tactical assumptions. Luftwaffe pilots who'd grown confident in their ability to climb away from pursuing P-47s began experiencing situations where the Americans matched their performance. The climb advantage that German fighters had exploited for 18 months disappeared almost overnight. The statistical evidence appeared within 60 days. Between mid-April and mid-June 1944, 8th Air Force P-47 squadrons recorded a 16% increase in FW-190 kills despite flying fewer escort missions as they transitioned to ground attack roles in preparation for the Normandy invasion. More significantly, P-47 combat losses in engagements below 10,000 feet decreased by 22%. Robert Johnson survived the war with 27 confirmed aerial victories, making him one of the top American aces in the European theater. He was awarded the Distinguished Service Cross for actions on June 26, 1944, though the citation made no mention of his March 15th discovery. Johnson himself rarely spoke about the flap technique, later writing that he'd simply done what seemed logical in the moment and was surprised when it became formal doctrine. The technique spread beyond the European theater. By August 1944, 5th Air Force P-47 squadrons in the Pacific were using combat flaps in engagements with Japanese fighters, particularly the Nakajima Ki-84, which shared the FW-190's ability to outclimb standard P-47 operations. Pilot reports from the 348th Fighter Group noted that combat flaps gave them options they'd previously lacked in vertical maneuvering against the best Japanese fighters. The Luftwaffe eventually recognized that P-47 climb performance had improved beyond published specifications. A captured document from September 1944 warned German pilots, "The P-47 has demonstrated climb capabilities that exceed previous intelligence assessments. Do not assume altitude superiority in climbing engagements below 4,000 meters. Post-war analysis by both Republic Aviation and the Air Force calculated that the combat flap technique likely saved between 40 and 70 Thunderbolt pilots in the European theater alone. These pilots survived engagements they would otherwise have lost, or avoided situations where German fighters could dictate terms from superior altitude positions. The discovery influenced post-war fighter design philosophy. Aircraft engineers began examining performance envelopes more critically, questioning whether conservative structural limits were leaving useful capabilities unexplored. The concept that high-lift devices could enhance combat performance in ways beyond their intended function became part of fighter development methodology. Several Korean War-era jet fighters incorporated combat flap schedules into their operating manuals from initial design, rather than discovering the technique operationally. The North American F-86 Sabre's combat flap procedures, used extensively in engagements with MiG-15s, drew directly from lessons learned with the P-47. Ironically, the German fighters that had so dominated climbing engagements in early 1944 were themselves flying with suboptimal technique. WWII pilots had been trained to climb at specific power settings and airspeeds that maximized engine longevity. Post-war testing of captured WWIIs revealed they could produce even better climb performance with more aggressive power management, but fuel constraints and engine reliability concerns had prevented Luftwaffe pilots from exploring their aircraft's absolute performance limits. The story of combat flaps stands as one of those rare instances where a single pilot's desperate improvisation became standard doctrine. Johnson didn't discover an engineering flaw in the P-47. He discovered that conservative peacetime testing limitations had obscured combat capabilities that existed within the aircraft's structural margins all along. Innovation in combat rarely comes from engineers and test pilots working in controlled conditions. It comes from desperate soldiers who lack the luxury of following approved procedures because following procedures means dying. Johnson's discovery teaches something fundamental about the relationship between doctrine and survival. Manuals are written by people who've never been shot at, refined by committees that prioritize liability over lethality, and printed with prohibitions that assume perfect conditions. Combat has no perfect conditions. Combat has target fixation and closing rates, and seconds to decide. Combat has Germans climbing away, and dead wingmen and a flap lever your hand finds, because every other option leads to the channel. Republic Aviation built the flap system strong enough to handle combat loads. The engineers just didn't know they'd built it that strong because no one had tried to break it the right way. The manual said don't try. Johnson tried anyway because trying meant maybe living, and following the manual meant definitely dying. March 15, 1944, 8,000 feet above the Normandy coast. One navigation error, one split-second decision, one prohibited control input that saved one pilot and changed tactical doctrine for every Thunderbolt squadron in 2 theaters of war. Sometimes the most important thing you can do is ignore the manual and trust what the machine is telling you through the stick. The manual protects the aircraft. The pilot protects himself. Superior engineering matters. Desperate innovation matters more.